Hi! Welcome to my class. Our topic for today is to solve one-step inequalities. We're going to use addition and subtraction properties to solve inequality equation. Then we are going to use also multiplication and division properties to solve inequalities equation as well. The base of our lesson is the inequality symbol. Just remember what we have learned before. Just remember, if you are plotting it on a number line and if it is less than or equal to, the dot must be open. And if it is greater than or equal to or less than or equal to, the dot must be closed. Now, I want you to listen very well. When you add or subtract the same number from the side of an inequality statement, the inequality stays true or correct. For example, 4 plus x is greater than 7. Let us solve this. You are going to deal with the number which is together with the variable side. So in this case, we're going to deal with 4 because it is together with x. 4 plus x. What are we going to do? We're going to change the sign of 4 to eliminate it on the left side. So 4 minus 4 is equal to 0. 7 minus 4 is equal to 3. Therefore, x is greater than 3. How are we going to graph it? We're going to locate number 3 on the number line and we're going to make the dot open. And then I want you to look at the symbol. It is pointing to the right. Therefore, the arrow will go to the right. And all the numbers to the right are bigger than 3. Now, let us work on the second example. It is x minus 2 is less than 12. What are we going to do? There's the variable and the number on the left side, so it's negative 2. We're going to add 2 on both sides. Now we can eliminate 2 on the left side. 2 minus 2 is equal to 0, and 12 plus 2 is equal to 14. Therefore, x is less than 14. Where is the inequality symbol pointing? To the left. So, the arrow will go to the left. And all the numbers to the left are smaller than 14. Now, let's work on this example. Solve y plus 5 is greater than 18. Graph the solution on the number line. What are we going to do? The number together with the variable is on the left side, and it is plus 5. So, we're going to subtract 5 on both sides. 5 minus 5 is equal to 0, and 18 minus 5 is equal to 13. Therefore, y is greater than 13. How are we going to graph it now? We are going to locate 13 on the number line with an open dot. And again, look at the inequality symbol. It is pointing to the right. Therefore, the number line will go to the right. And all the numbers to the right of 13 is bigger than 13. So these are most probably the values of y. Let's do another example. Solve x minus 12 is less than 20. Graph the solution on the number line. Which number is together with the variable? It's 12. X minus 12. So what are we going to do? We're going to add 12 on both sides of the equation. Minus 12 plus 12 is equal to 0, and 20 plus 12 is equal to 32. Therefore, x is less than 32. Where is the inequality symbol pointing? To the left. We're going to plot number 32 on the number line with an open dot, and the number line will go to the left. Now, when you multiply or divide each side of an inequality by the same positive number, the inequality remains true. Let's work on the first example. 4x is less than 20. This time, what are we going to do? The number together with the variable is on the left side and it is multiplication. So we're going to divide 4 on both sides. 4 divided by 4 is 1 and 20 divided by 4 is 5. Therefore, x is less than 5. We're going to locate number 5 on the number line with an open dot and look at the arrow. It is pointing to the left because the inequality symbol is pointing to the left. So, all numbers smaller than 5 are the values of x. Now, let's work on the second example. X over 2 is greater than 12. This time, it is division. What are we going to do? Since it is division, we're going to multiply 2 on both sides. So, 2 divided by 2 is 1, and 12 times 2 is 24. Therefore, x is greater than 24. We're going to locate 24 on the number line with an open dot, and the number line will go to the right because the inequality symbol points to the right. All the numbers to the right of 24 is bigger, and those are the values of x. Let's try another example. Solve 6x is greater than 30. Graph your solution in the number line. Since 6x is multiplication, we're going to divide 6 on both sides. 6 divided by 6 is 1, and 30 divided by 6 is 5. So, x is greater than 5. We're going to locate number 5 on the number line with an open dot, and the line will go to the right because the inequality symbol is pointing to the right. All the numbers bigger than 5 are the values of x. What about this example? Solve x over 3 is less than 4. Graph your solution in the number line. Since the variable is divided by 3, we're going to multiply 3 on both sides. Working on the inequality equation, 3 divided by 3 is 1 and 4 times 3 is 12. Therefore, x is less than 12. We're going to locate number 12 on the number line with an open dot, and the line goes to the left since the inequality symbol is pointing to the left. Therefore, all the numbers smaller than 12 are the values of x. Let us solve x over 3 is less than or equal to 4. Graph your solution in the number line. Since x over 3 is division, we're going to multiply 3 on both sides. 3 divided by 3 is 1, and 4 times 3 is 12. Therefore, x is less than or equal to 12. We're going to locate number 12 on the number line with a closed dot because it might be equal to x. And the inequality symbol is pointing to the left, therefore the arrow is going to the left. And all the numbers smaller than 12 are the values of x. Now again, it's the same example, but this time it is greater than or equal to. Solving 6x is greater than or equal to 30 and graphing it on the number line. Remember, if it is multiplication, we're going to divide the number that is together with the variable. In this case, it is 6. Therefore, divide 6 on both sides. 6 divided by 6 is 1 and 30 divided by 6 is 5. Therefore, x is greater than or equal to 5. This time, we're going to locate number 5 on the number line with a closed dot because it might be equal to x. And the inequality symbol is pointing to the right. Therefore, the number line is going to the right. All the numbers bigger than 5 are the values of x. To wrap it up, when you add or subtract the same number from the side of an inequality statement, the inequality stays true or correct. Like this example. The first example, it is addition. You subtract on both sides. Therefore, you will come up with x is greater than 3. Locate number 3 with an open dot, and the number line will go to the right. On the second example, it is minus. So, x minus 2 is less than 12. Add plus 2 on both sides, you will come up with x is less than 10. Therefore, locate number 10 with an open dot, and the number line will go to the left. In this example, the questions are the same, but there is an extra line below the inequality symbol. So, the difference is, you're just going to make the dot close. And the same step will apply. When you multiply or divide each side of an inequality by the same positive number, the inequality remains true. So, when the inequality is multiplication, work on it by dividing the number together with the variable. In this case, you divide it by 4, therefore, x is less than 5. And still, the dot is open going to the left. And the second example is division, so you're going to multiply both sides by 2 in this case. So x is greater than 24. Still, the dot is open going to the right because the inequality symbol is pointing to the right. Now, I wrote the same example, but I just put an extra line below the inequality symbol, meaning it is greater than or equal to or less than or equal to. The difference is only the close dot. When there's no extra line below the inequality symbol, the dot is open. But if there's line below the inequality symbol, the dot is closed. Math is easy, right? Till next lesson. Bye-bye.